For us,
Oh,
people with small screens, this is just readable.
yeah. Okay, well, let me tell you a little bit about my project. So for my midterm project, I decided to work on the Great Resignation. I'm sure everybody's seen this in the news about people just, between COVID and job dissatisfaction, just not wanting to, um, work and just, I quit. So at first I was really excited. I thinking I could find and make my own cool data set, but given the limited time, I found one that was online. It's a lot smaller than I was expected, and it was less than 15,000 records, and it had 9 independent variables. And essentially we were doing a classification of, is somebody going to quit or are they not going to quit? So basically this is only from one company. So that's another thing. It would have been a lot more interesting, a variety of companies, more recent data. But I decided to use a couple different classification methods: logistic regression, decision trees, random forests, support vector machines, and XGBoost. And because it's a pretty imbalanced data set, most people don't quit their job. Instead of accuracy using the area under the receiver operating characteristic curve, ROC is a bit more recommended in the field because with accuracy, you might do a really good job predicting the majority class as opposed to both classes or the minority class. So I describe a little bit about the project structure and how I built it. I do have some little trip ups because I'm working on a Mac. I had never even heard of this system version compat, and I have to say thanks to the rest of the class for helping me figure those kinds of things out. I'm going to skip over to the notebook for now. Okay, that looks really funny. I don't know. Let me see. Let me bring it up over here.
Yeah, you cannot hear me. Maybe you can just maximize your window. That will look better.
Okay.
Or is there such a thing as maximize on Mac? I don't know.
It's as big as my window right now.
Yeah, it's fine. I think you can hide this thing here exactly.
There we go.
Here.
Yeah,
okay. That's good. Thanks.
Okay, so also because this was on Kaggle, everything's filled in, so there wasn't a lot of missing data. I'm gonna scroll down. These were just some samples, and you can see nothing missing. I did the typical split into 60, 20, 20s for the training, validation, and test set. I took a look at some of the fields to see what was going on and get an idea how many unique things for like the categories. These are the different types of jobs at that particular company. And this is how much their salary. It's not an actual number, it's just low, medium, or high. Certain things, you can see this better down here. Certain things, monthly hours, not quite normal. Number of projects, not quite normal, but close. And then certain things like promotion in the last 5 years, almost nobody was promoted. Almost nobody had a work accident. So I decided to throw those two out from my analysis. You can see most people were in sales and most people were paid pretty low, I guess. So I did try to group them a bit by categorical features to see kind of, what kind of relationships they had. I did the heat map. And then after that is when I threw out the work accident and the promotion within the last 5 years, because they were pretty low. Tried a little bit with the mutual information scores to see, again, not a lot of things were related to each other. A little bit of narration there of what I found specifically. So I dropped these two features, redid the correlation analysis, encoded the categorical data, and then I tried fitting my model First with the logistic regression, you can see the coefficients. Let me know if I'm scrolling too fast or too slow. And
That's
then,
fine.
okay. And then doing the probability of prediction. So on each model, I kind of saved off, there's actually also a feature in sklearn with the balanced accuracy where they try to, make sure that both the majority and minority classes are handled. So I checked all of them, but basically I used the ROC AUC later on. So also tried the decision trees to see, and just tuning a few parameters at a time. So here they are, different things that we're checking in. And I use the, advanced technique of eyeballing to pick the max depth and the minimum sample leaves for each one. And you can, what's nice about decision trees is you can see very clearly how it breaks down, like, at this level, if it's above this level or equal to this, it falls into this part of the tree or that part of the tree. I do also have like a visual that's a little easier to read in this sense, on how it decides whether somebody's going to quit or not and the probabilities.
The color here, do you know what it means? It's like blue 0 and red 1? Or do you know?
Actually, I do not know. I would have to look that up.
So this is my gut feeling, like how, because maybe if you scroll up and look at some of the, I think the right, the how to say, like when we go right, most of them are 0, right? So 0, it probably means red. Or no? Yeah, that's interesting.
There's less than 0. You could be right. I would definitely need to look that up to be sure.
That's 3.plot3, right? To get this picture.
Yes.
It's probably won't work with very deep trees.
Yeah. I tried a couple other things and like the image just became crazy. You really couldn't see anything. So not having too much depth or too many, items to like visualize. I finally got it to a point where it's like, okay, you can actually kind of see. And you can do like tree pruning and things like that. I didn't go that way on this one. So then I moved on and tried random forest, which is just a collection of trees, and tried tuning that on different things like max depth.
Yeah, that's pretty high AUC there. It's training one, or I mean, on the graph, that's training one, right?
So I estimated it as 15, again, with my tricky eyeballing technique, a max up of 15 and estimators at 30 to get the best AUC on this. Just trying that again, different min samples for each leaf. And tried to show the visualizations for how well each of these did. Here I was trying by the bootstrap. Sometimes it helped, sometimes it didn't. I find that, when I'm rerunning stuff, sometimes it changes a bit. So I decided to use 190 estimators, no bootstrapping, max depth of 15, and min sample leaves of 1. It was doing pretty well in predicting. So here you can see like the probabilities, and I did a feature importance. So as you may have guessed, satisfaction level is the biggest as to whether somebody's going to leave a company or not.
Wait. There is something interesting that I see. So this sorted fi.style.highlight max. That's so it just shows the first one, right? So it puts it as yellow.
Yes.
Yeah, that's a nice one.
And then my feature importance, again, satisfaction is really the big driver.
So satisfaction, and the second most important feature is time spent at the company, right? At the company.
Yeah, and number of projects.
Okay.
They're
So
about, at least for me, it looks about the same.
do you remember what's the relationship there? The more projects people work on, the less likely they are to leave, or the opposite?
I forget offhand. I think they were less likely because it seemed like they were more engaged, but I'd have to double check. This was a couple weeks ago already.
And this average monthly hours, I guess, is like if they need to work more, then they are more likely to leave as well, right?
Yeah, over time, kind of,
Yeah.
you know, of course, it kind of a little bit correlates with the number of projects because, you know, more projects, you probably have to put more work in.
Yeah, right.
That part I did remember. Again, for the support vectors, again, satisfaction level was the biggest. I did try XGBoost and testing different things like the learning rate, and doing different models to see how that worked out. The max depth, also the how much you should weight the child. So I did try different parameters. There's so many more you could do, but in an effort to, you know, keep it small, I only tried a few of them. And so you could see different ones, and then I picked the best of the models for that. So I took model of my XGBoost model 3 with the max depth of 10. And then when I get down here, I compared all of them and decided they're both pretty close, the random forest and the XGBoost on our ROC. On our, so I went back and retrained on the full data set, training and validation, and tried both of these two. Since they perform well on, you know, earlier, I was like, okay, let me try the two top models. And I reran on those. And then it turned out random forest did a little bit better. So that's what I used for my deployment. Of course, it's kind of low. It seems like half the time you might get it wrong. So it's kind of like flipping a coin. So I would do a lot more to, you know, try different models, see if I can do some ensembling to see if I could get better results. Because usually if you combine a bunch of low performing models, you might be able to do better with the ensembling. So am I running predict? Let me run that in the background. Oops. Okay, that is not good. I'm not sure what happened there. I've run this previously. It's only because you're watching, I'm sure, where I tried 3 different employees and to see whether or not they would quit by just kind of changing different factors of, you know, how high their satisfaction level, how many projects, things like that, to see what's the likelihood that they would quit. This one is, oh, I know probably what I forgot to do. Oh, I did do that. So what I did want to show you is,
Does look quite strange.
yeah, it does. So and in the testing, I did try testing it locally. I tried testing it, you know, using Flask locally. Minad had given me great directions for how to deploy it, how to build it in Docker. I was able to do that over on the Google Cloud Shell, which is free. So I packaged up the essential files. And then from the Google Cloud Shell, I deployed to Heroku. And just so you can see that my Heroku app, oops, I probably should open that separately. It's not a very fancy one. Basically, this just lets you know that the app is up and running. So then when I run, oops. Hopefully it should run. Yep. So it's going over to the Heroku server, which is owned by Salesforce, but it's free. And it sent up over here another example of here's a particular employee, and then requests, it posts the request and parses the URL back to say, hey, what's the chance of this person quitting? So in this case, they probably won't quit. Any questions?
Yeah, how was your experience with this Google Cloud Shell? So I saw that you used it, and I'm quite curious, how does it work? Is it just a usual shell, or what are the benefits?
Well, I was having a little trouble with Docker on my machine, so that's why I just was able to, build everything over there. And it was really quite easy. The only thing that, as usual, you have to think about, which OS you're on certain things. And, without the instruction from Ninad, it would have been really hard, to deploy to Heroku, just because this is like my first big deployment. So there was a lot to learn. And without the instructions, I probably wouldn't have gotten there in 2 weeks. But it was quite easy once, trying things out, and both the Google Cloud Shell was free and the Heroku was free. And what's nice about the Heroku stuff is that it just sits there in the background. So it kind of shuts down if you're not using it. So I did test it, run my little test page just to kind of wake it up beforehand. Probably would have been nicer have a better front end interface to know that it's actually working, but you only had 2 weeks kind of thing. So yeah, so I was pretty excited and happy that it all worked end to end. Yes, the models could have been better. There's more you could always do on this, but for the basic bare bones, I think it worked pretty well.
Yeah, that's why we have a deadline in 2 weeks, because
yes.
If it's 4 weeks, I'm sure like every one of you will spend all these 4 weeks trying to come up with the best model, right? Yes. And then maybe last couple of days you would spend on deployment. Okay, so are you using, do you use this Google Cloud Shell for your capstone project as well?
No, I didn't. Because we were doing Lambda functions, I didn't need to. And then I did get the right version of Docker installed locally. Okay. So everything worked just fine. So I just did it from my desktop over to Amazon with the ECR and Lambda functions. So right now it's working.
Great.
Writing it up.
Cool. Let me see if we have questions. So I don't see questions to you specifically. So if anyone have questions to Lisa, please write in chat. Yeah, maybe I'll ask you something. So what was your best learning? Like what you like? Maybe let me phrase it like that. What's your main takeaway from this project? What you enjoyed most doing?
Well, I liked all of it. I really wanted to kind of make my own data set and have it more up to date. So I was a little disappointed in, it wasn't as easy to find things as I thought, or I tried building some data sets, like, maybe predicting, volume of wine, depending on like fires in a particular area in California, because, something new and relevant to the news. But then certain things you would think would be a piece of cake to find. What's the volume produced by different wineries? It was actually really hard. So I gave up on that. And I was like, okay, well, what else is in the news? So that's why I went with this topic. And what I really liked, I had learned to, in terms of the algorithms, I knew them, but the deployment part was very new to me. So that was quite interesting. And yeah, so I was glad to get experience with that part.
Okay, so for you, the way you approached picking up the problem to work, so you checked what is hot in the news, so what is trendy, and then based on that, you decided, okay, let me dig a little bit deeper in this, how it's called, Great Resignation, or?
Yes.
Okay.
Yeah, I mean, I love watching some of the articles that, like, you know, the New York Times or the Washington Post does, you know, like, you know, here's something relevant and here's a good visualization and here's what's behind it. Although if you pick it too new and don't have enough time, getting the data source was hard. So that was a big learning for me.
Okay, thanks for sharing that. I don't see questions. So there is a question from Tejas, but I don't think I understand it. So how to know which Docker supports? Yeah, maybe you can rephrase it a little bit because I am not sure I understand it. Oh, I think you have your camera off.
Me?
Yes, you.
Oh, it went off. Oh, sorry.
No worries. What is on your background? Is it?
It's just ocean.
Yeah, nice. Okay, then I see there is one question in Slido. So let me share my screen. So the question is, how do the following techniques compare for hyperparameter tuning features singly, tuning them together using grid search? Do you have any idea, or should I try that?
Well, I thought by doing them singly, it was a little more hands-on. You know, a lot of times I would just try grid search, but I think we were trying to demonstrate, you know, oh, we have skills that we can actually, you know, try these. I have used things like Data Robot, things like that, which are great for like, okay, let me try like, say, you know, 100 models, but then you usually have your own business sense or subject matter expertise. And so you kind of know like, okay, well, maybe this influences things more. So something like either the grid search or the Data Robot kind of auto machine learning is that I think it's a good place to start. I mean, I wouldn't, you know, just use that. I mean, and also what's nice about Data Robot is you can put your own models in. So, but it's really handy in terms of saving you time. You know, you saw how long the notebook got when I tried, okay, let me just tune the learning rate, or let me just tune, you know, different things. So grid search does it a lot faster. And, you know, some of the auto machine learning will dump out, you know, here's your charts, here's your comparison, your leaderboard, so much faster than I could code it. So I think they each have their place. Depends on what your use case is, I guess, you know, how fast you need to get something done, what's your goal, that kind of thing.
Yeah, Data Robot, it's like you just give it a data set and you press a button and then it does some magic and then it gives you the best model, right? This is how it works, doesn't it?
Pretty much you can only have one data set. So everything has to be prepared in that data set to go. And, you know, you can tune a bunch of things. I mean, what's nice is that you can have like the intern run it or the PhD, you know, so the intern may not know as much about, you know, the subject matter or how to work with it. I think both can use those kinds of tools.
Yeah.
But yeah, it is a big button to start with.
So the way I would answer this question is, so there are of course advantages and disadvantages. Both have their, how to say, like both deserve, you know, you should try them. So I would go with grid search if I know that my data set is small and I can try to fit a lot of models. So let's say if we have only a couple of thousand observations in our data set, then training a single model doesn't take, let's say, more than 1 second or 2 seconds. Then you can go crazy and test as many combinations as you want. Because what grid search is doing, it's trying every single combination. Like let's say you have the C parameter, then you have three parameter. Let's go with random forest. So you can try with bootstrap and without. You can try a number of estimators, this or that. You can try max depth, this on that, and that it basically creates like I don't know, 50, 100, 1,000 different combinations. So if your data set is small, and fitting one model doesn't take a lot of time. You can just go with that and then see. But usually when you have a relatively large data set, like already like 20,000, 30,000, and then fitting one model takes some time. So it's not 1 second, maybe it's 10 seconds, 20 seconds, 30 seconds. And then try and grid search is just takes forever. And then this is when I would actually go and try to tune features singly, exactly like how I showed it in the course. So for example, with XGBoost, like I would start with, so what I showed was more like a heuristic, which works usually for XGBoost. It doesn't give you the best parameters necessary. So maybe with grid search, if you give it enough compute, grid search would find better parameters than when you do this feature, when you tune them single. But you can find an okay solution faster. So that's like two. So B, grid search takes a lot of time, but finds a better solution, more optimal one. A takes less time, it's more manual. But if you have a large data set, you can arrive at an okay model faster. So that's it, I guess. So I don't see any other questions. Yeah, if you have questions, of course, ask them in Slack. Oh, there is a question in live chat. I'm facing problems in data cleaning. What techniques are good for data cleaning if we have large amounts of data? Lisa, do you know?
There's all kinds of things. Like, do you have missing data? Do you, like, is it text data? Like sometimes you need to do some like cleaning. So like if, you know, street is ST and STREET, you know, you might want to combine them. If there's like, you have that missing data, you might want to take an average or median. If it's outliers, you might want to, you know, depending if it makes sense or not, you might want to throw that out. You know, say like Elon Musk's salaries in your data set, that might not be a good model to go on because not everybody.
I think his salary is 0, right? He wrote recently in his tweet that he doesn't have any salary. All his like he only has shares.
Yeah,
so he would be an outlier, but in a different.
Yeah, in the other direction actually.
Yeah.
So yeah, so things like that you would want to look out for. You might, you know, use interquartiles and cut off the tops and the bottoms. There's a lot of different techniques you can use.
Yeah, and this is like data cleaning is very broad and also very abstract, and unfortunately, it's very manual. So there is no magic big button like in data robot. It would be nice if you give it a bunch of dirty data and then like there is, you know, this magic wand button that's like a large one. You click on this and then your data becomes clean. That would be a nice data robot. Then like so like maybe you can have 2 buttons, make my data nice, make my data clean, and then okay, now find the best model on this data. Maybe there is some research in automated data cleaning as well. There must be something, but
there are some companies out there, and you know, some of the companies have been like buying each other up and consolidating, so that the trend seems to be like the end-to-end, you know, also deploying the models and, you know, machine learning ops to make sure you don't have like data drift and things like that. But it's not always as robust as you might want for your particular situation, because, you know, they try to generalize when they build the tools. So yeah.
Okay, I guess I don't see any more questions. Thanks a lot for your presentation. Yeah, I hope I already shared the link, so I think it was very useful. So the link is there. I also put it in the description. Do check it out. All the code is there. Yeah, thanks for sharing.
Thank you. Thanks for having me.
Yeah, and have fun with your capstone project, you and everyone else who is watching this. So yeah, as I mentioned while you were away, so this is the last office hours session we have this year. So we will have a break, but of course, if you have any questions, we have Slack, and go ask your question there. And yeah, so enjoy your holidays.